Okay. Good evening once again. Good evening, everyone. So we will start today's class. Now, before last class, tell me, anyone, what we have studied till last class? And if any one of you, those who can keep your videos on, they can keep your videos on. At least I'll have this idea that I'm teaching someone. Okay, because it seems quite boring to teach without seeing someone. Okay. So if any one of you can keep your videos on, you can keep, okay, right? Okay, yes, we talked about spherical mirrors. I hope we completed our reflection, right? Okay, we completed reflection and we just, yes. So we gave the basic of refraction, okay? So today we are going to discuss more about refraction. I hope all of you, right, are comfortable with using mirror formula. Tell me guys, we have solved lots of problems on mirror formula, right? Sign convention and all. Everyone, anyone have any doubt in mirror formula? Tell me. Abhiram, Abhilash, Ananya, Harsh, Monica. There are many people whom I haven't seen actually. I have like Zam is not here. I have okay, Zam is here. One day we'll just have this hi hello session. Okay, because there might be some people whom I haven't seen or I might not remember the face, especially the new one. Okay, so we will start with refraction. Okay, I hope all of you remember the concept of reflection and all. Okay, now when we talk about refraction, let's think about this, right? I gave this example to class 8 students that what is the basic phenomenon of refraction. Now, suppose you are running, right? Suppose you are running in like on a concrete road, suppose, right? And then suddenly you get a sandy road. Okay, what will happen? What do you think, right? Or sandy road means full of sand, right? The type of sand which is available in desert, right? What do you think? What will happen? What will happen to your speed? Tell me, what will happen to your speed? Kya hoga? Speed will decrease. Makes sense, na? Speed will decrease. Yes, you will slow down. That's a basic common sense. That's a basic intuition, or right? Yes, very good. Now, why that happens? Think about it. Because you can feel, okay, there might be many reasons for that. Okay. Now, just think about light, right? Think about light. We know that when light travels, it has some speed, yes or no, right? It has some speed, it has some frequency, it has some wavelength that we have already studied. Okay. Now, what is the difference between water and air? Think about it. Can you swim in air? Think about it. Can you swim in air? No, right? But we can swim in water. Yes or no? Right? Why? Because I can say that if I have to say, okay, the density of air is less than that of the density of water. Okay. Or there might be some other physical phenomena like viscosity, but I'm not talking about viscosity for now. I'm just talking about the density. Can I say that, okay, density of water is more than the density of air? Yes. Okay. Now, density is very easy to understand because it is just mass by volume. But when you talk about objects, when you talk about light, okay, right, or objects in which light is passing. So in that case, there's something called optical density. There's something called optical density. Optical density, right? Optical density. Okay. So what is the meaning of optical density? It is basically the nature, right, of material, okay, which makes or basically through which a light is passing. Now, when you talk about these two cases, right, think about it. We have one medium, which is air, and second medium which is glass. Now, we know that intuitively, I can say that, okay, air will be having less density as compared to glass, right? Forget about, you don't know about refractive index, anything. You don't know anything about that, right? If anyone asks you intuitively, what do you think? Whose density would be more, air or glass? Intuitively, right? Just think about intuitively. What do you think? Whose density would be more, air or glass? Even if you don't know the actual meaning of optical density, you might feel now, okay, glass ka zyada hona chahiye, right? Yes, very good. Okay, right? Yes, the optical density of glass is more than that of the air, right? Step by step. Okay, so if I'm saying that the optical density of glass is more than that of the air, what will happen to the speed of light? What will happen to the speed of light? Tell me, kya hoga? Decrease. Very good, Krish. It will decrease. Very good. Now, right? It will decrease. Very good. Now think about it, right? This is what happens. This is what happens when an object, right? Sorry, when ray of light is, right, traveling from one medium to other medium because of change in speed of light, right? See, actually it's change in wavelength, right? But I'm talking about speed of light. Okay, change in speed of light, there will be deflection. There will be deflection. For example, if you see this, right? Let's see this. This is your incident ray. Okay, this is the incident ray, right? Now, suppose if there's no change in speed, suppose there's no change in speed, right? What will happen? I can say that, okay, the speed, if not changing, the speed is not changing, then light will go like this, yes or no, right? Yes, but actually it doesn't happen. Okay, actually the speed of light changes. So if it changes, right, it will slow down, right? It will slow down. And when it slow down, it try to shift toward the normal, right, everyone? Right? This is what happens. And this phenomena is called as refraction, right? This phenomena is called as refraction. So I can say that, okay, the refraction is a phenomena in which light bends. Light bends when it passes through one medium to other medium, as simple as that, राइट ओके अब लॉजिकली सोचेंगे, कुछ याद नहीं करेंगे, अगर कुछ सोचो, अगर लाइट एयर से ग्लास में आ रहा है तो उसका स्पीड स्लो होगा, and if it is decreasing, the speed is decreasing, then I can say that it will bend toward the normal, right? Everyone tell me yes or no. Yes or no, it will bend toward the normal. Okay, so I guess this is very easy concept that all of you already know, that light travels from one medium to other medium. If light travels from one medium to other medium, it bends. Okay, that phenomena is called refraction. That happens because of the difference in optical density of the two materials. Because of that, the speed of light changes. Okay, right? Now, the material in which, right, the material in which, or the material of which the optical density is more is called as denser medium. It's called as denser medium. And the medium in which the optical density is less, it's called as rarer medium. Rarer medium, right? Okay, got it? So this is the basic definition. I hope all of you understood the basic definition. Because you guys know English, you can write it down in your own language. Okay, now after this, when we talk about the components, so we will just take the analogy of reflection. When we talk about reflection, we have incident ray, normal, and reflected ray, right? In the same way, don't you think that the same thing will happen over here, right? We will have your incident ray, normal, but instead of having reflected ray, we will have refracted ray. This is your refracted ray, right, everyone? Right? Okay. Now, this is first thing. The second terminology is angle of reflection, angle of incidence, that we studied in reflection. And in the same way, the angle of incidence will be same, right? The angle of incidence will always be same. What is the angle of incidence? It is the angle between incident ray and normal. Angle between incident ray and normal. So it doesn't matter if it's reflection or refraction, it will be same. When we talk about refraction, right? The definition should be same. The definition will not change, right? So I can say that, okay, when we talk about reflection, it was angle between reflected ray as well as normal. What do you think about refracted ray? Now, when we talk about refracted, it is the angle between normal and refracted ray. That is the angle of refraction. Okay, right? So that's the basic terminology. Okay, so till now I understood what is refraction. I understood what is the meaning of optical density, right? When optical density is more, the object is denser. When optical density is less, it is rarer, right? What is angle of incidence? What is angle of refraction? What is incident ray, what is refracted ray, how the light bends, okay, when it moves from rarer medium to denser medium and denser medium to rarer medium, right? Okay, now think about it. What do you think? What is this angle, right? What is this angle? Tell me, this red angle, right? What is this angle? Or in this case, what is this angle? Suppose this angle is theta. I'm just saying this angle is theta. What do you think? What this angle is? Tell me. All of you know this, right? Yes, very good, Dhruv. Very good, right? Anyone else? Anyone else? No, not emergent ray, right? This is called as, I'm talking about the angle. I'm talking about the angle, right? That is called as angle of deviation. Okay, angle of deviation. Think about it now. Think about it, right? Because when you talk about the dotted line was the actual path of incident ray, yes or no? The dotted line is the actual path of incident ray, right? But the ray will actually deviate, right? The ray will actually deviate because of the change in speed. So that's why this change in angle is called as angle of deviation. Got it? So this is called as angle of deviation. Angle of deviation. Okay, right? Okay, very good. Now let's see. So this is what we have already studied. What is the cause of refractive index? Right, sorry, refraction. The cause of refraction is the optical density, right? Is optical density. So we have optical rare medium, optical denser medium. Because of that, the speed of light will changes, right? Right, and because of that change in speed of light, there will be deviation in path of light. Okay. Now, if I ask you, what are the laws? Tell me, what are the laws? Think about it, right? Think about it. Just relate the concept with reflection. When you talk about reflection, we have one concept, right? Okay, what was basically, we have two laws. What was first law? Tell me, what was first law? The first law states that angle of incident, angle of reflection. I'm talking about reflection. I'm not talking about refraction yet, right? And normal are in the same plane. Yes or no? Tell me, yes or no? Tell me, guys, yes or no? Yes. And second law was angle of incidence equal to angle of deflection. So one is about the incident ray, reflected ray, and normal being in same plane. Now, what do you think? What do you think in refraction? Don't you think that the same principle, the same rule will holds true? Tell me. Don't you think that the same rule will holds true? Because when you talk about refraction, right? In refraction also, now the incident ray, refracted ray, as well as normal will be in same plane, right? Yes. So that is your first law. Okay, first law is same. First law is same. The incident ray, refracted ray, and normal, right, to the surface separating the two medium will all lie in the same plane, right? Now, second is something related with the angle, right? The second thing is something related with angle, but it's not as easy as laws of reflection. The second law is called as Snell's law. It is also called as Snell's law. It states that the ratio of sine of angle of incident, sine of angle of incident by sine of angle of refraction. I hope all of you have studied me. Yes, पता है ना साइन क्या होता है? पता है कि नहीं? Okay, very good. Is a constant, is a constant. Now this constant is called as refractive index. So basically it is mu to 1, right? There are many ways to write it out, but I'll just write it as mu r by mu I, right? I'll just write it like this. Refractive index, I'll tell you what is this refractive index, right? I'll just write mu r by mu I. So the easier equation that I'll be using is mu1 sine I is equal to mu r sine r. So mu1 is the refractive index of the, tell me, that medium in which incident rays is there, and mu r is the refractive index of the refracted medium. Makes sense, right? Makes sense. So this is what we will use, right? Actually, both are same. Okay. So either you write n21, mu21, or mu21, doesn't matter. Everything is just a notation. Okay. Right. And this law is called as Snell's law. Got it, everyone? Tell me, got it? Now, the next term is, okay, what is this constant? What is this refractive index? Now, think about it. Think about it. Suppose, suppose when you talk about any medium, right? Suppose you talk about glass or water, right? The speed will be different. No, the speed will be different. Yes or no? In some cases, it will be fast. In some cases, it will be slow, right? But we have to take one reference speed. Yes or no? Tell me. Yes or no? Tell me. Yes or no? Yes. And what is that reference speed? That reference speed is the speed of light in vacuum. Yes, speed of light in vacuum. Okay. Now, can I say that, okay, the speed of light will either increase or decrease, right? Okay, it won't actually decrease, but it will not actually increase, because when we talk about speed of light in vacuum, it will be the maximum. Yes or no? It will be maximum. Speed of light will be maximum in vacuum, right? Speed of light is maximum in vacuum, right? Yes or no? Is maximum in vacuum. Okay, so I can say that, okay, whatever the medium is, the speed of light will always be less than the speed of light which is in vacuum, right? So I can compare the speed of any speed of light in any object, any medium. Yes or no? I can compare the speed of light in any medium with respect to speed of light in vacuum, right? Let's do that. Suppose I want to compare, right? I want to take the ratio, right? I'll just take a ratio, random ratio k, which is speed of light in vacuum by speed of light in medium, right? Now tell me, this ratio, right? This ratio is constant for given material. Yes or no? This ratio will be a constant for given material. And what do you think? The value of this constant will be greater than 1 or less than 1? Tell me. The value of this constant will be greater than 1 or less than 1? Think about it. Always greater than 1, na? It is always greater than 1. Yes, right? Very good. Always greater than 1. Now, this ratio is called as refractive index. This ratio is called as refractive index. Now, you might ask, so why this, right? Why we didn't take the opposite, right? Why we didn't take speed of light in medium by speed of light in vacuum, right? The thing is, someone who started observing this, who defined this refractive index, right? It was according to him that we are following. Yes or no? If that guy would have said that refractive index is speed of light in medium by speed of light in vacuum, right? Then we would have studied that only, right? So there's no argument that why it is done. Okay, makes sense, na? Makes sense, right? So this is your refractive index. So we have absolute refractive index. We defined absolute refractive index. The absolute refractive index is speed of light in air or vacuum. Actually, it's vacuum, right? But we will consider that the speed of light in air is almost same as that of the vacuum, divided by speed of light in medium, right? Got it? And this is always greater than 1. This is always greater than 1. Now, this is absolute because we are comparing with vacuum. What is relative? Tell me, what is relative? Relative is always with one medium to another medium. Yes or no? Tell me, right? Suppose we have, right, refractive index of glass. Suppose refractive index of glass, right, is suppose we have 4 by 3. Suppose, right? Actually, it's of water, I guess. But anyways, refractive index of first object, I'll say. Refractive index of second object is suppose 3 by 2. Okay, now if I ask you, okay, out of these two, which will behave as rarer medium, which will behave as denser medium? Tell me. Out of these two, which will behave as rarer medium? Which of the two will behave as denser medium? Tell me. N1 or N2? Think about it. Medium, denser or rarer? Rarer, right? N2 will be rarer. Very good. Because we know that if refractive index is more, think about it, right? Think about what mistake some of you are doing, right? Some of you are doing, right? This medium will not be rarer. This medium will not be rarer. Why? Why? Tell me. Tell me. If N2 is more, refractive index is more, what does it mean? It means the speed of light in that medium is more or less. Tell me. If refractive index is more, then speed of light in that medium is more or less. Think about it. If refractive index more, speed of light will be more or less. It will be less, na? Tell me, yes or no? Just think about it, right? Now, if speed of light is less in any medium, it will be rarer or denser. It will be rarer medium or denser medium. Denser, na? Now tell me, out of these two, which is your rarer, which is denser? Right? Yes, because refractive index more, then the medium is denser. Okay, got it? Right? Again, Renuka, it is 4 by 3, it is 1.33, right? And it is 3 by 2, it is 1.5. Okay, so refractive index of N2, like this N2 is more, na? Right, Renuka? So tell me, N1 or N2, which is denser? N1 or N2, which medium is denser? N2, got it? Refractive index more, the medium will be denser. Okay? Now, if I want to compare one refractive index with other refractive index, right? So I'll write like this, refractive index of, right, object 1 with respect to refractive index of object 2. Think about it, what it will be, right? So I'll just write this notation. So it will be what? Refractive index of object 1, right, or medium 1 will be C by V1. Just think about it. Yes or no? I'm talking about speed of light as C. And this will be C by V2. Because this is something which students feel confused in. Think about it step by step. Yes or no? So this is equal to what? It will be V2 by V1. V2 by V1. Yes or no? Yes or no? And if you have, like, if you get any doubt, you can just think, nah, refractive index is inversely proportional to velocity of, right, light in the medium. Yes or no? Refractive index is inversely proportional to speed of light in medium, right? So it's always inversely proportional. So I can say that this is refractive index of light in first medium with respect to second medium is velocity of light in second medium by velocity of light in first medium, right? Or vice versa, velocity of light, okay, velocity of light or speed of light in first medium by velocity of or speed of light in second medium is refractive index of second medium with respect to first medium. Got it? You should think about the notation when you talk about n to 1, or I'll just use mu to 1. So it is second medium with respect to one medium, first medium. Got it? Tell me, got it? Right? Okay, very good. So I hope all of you are aware about refractive index. Yes, very good. Very good, everyone. Okay, so this is what I just derived. Okay, now if you think about the type of question that can be asked, think about it. If you talk about the type of question that can be asked, right? So we can ask a basic problem based on Snell's law. Yes or no? I'll give you angle of incident, I'll give you angle of refraction, and I'll ask you what is your refractive index or what is your relative refractive index. Can you find that? Tell me, can you find that? Okay, now don't you think that, okay, if I actually understood everything, I can say that if angle of incident is more than angle of refraction, if angle of incident is more than angle of refraction, then light is coming from which medium to which medium? Denser to rarer or rarer to denser? Tell me. If angle of incident is greater than angle of refraction, then right, it is coming from denser to rarer or rarer to denser? Logically. Yes, very good. Shreya, very good. Dhruv. Abhishek, think. Yes, Renuka, very good. It will be from rarer to denser. Rarer to denser. Right? Shuktika, it will be rarer to denser. Now, think about it. Think about it. Because even if you think logically, right? Okay, if it is decreasing, right? If it is bending toward the normal, then this should be a denser medium and this is a rarer medium. So it will be passing through rarer to denser. Got it? Very good, Zain. Got it, everyone? Because this is one confusion, right? Students generally get confused in this. Even though this seems quite simple, right? We just get confused. Okay? But I hope all of you are aware now. Right? Okay, very good. Very good. Okay. So this is what I was just saying. This is what I was just saying. If angle of incident is greater than angle of refraction, which means it is coming from rarer medium to denser medium. If angle of incident is less than angle of refraction, which means it is coming from, tell me, denser medium to rarer medium. Got it? Got it? What will happen if it fall perpendicularly, right? If it fall perpendicularly, I can say that there will be no deviation at all. There will be no deviation at all, right, everyone? Okay, very good. Now, I hope all of you remember I taught you something in last class, right? I taught you something about frequency and wavelength. How many of you remember that? How many of you remember that? That speed of light is equal to what? If you remember, speed of light is equal to what? Wavelength into frequency. Yes or no? Tell me, yes or no? Right? Now, I'm saying that if light is traveling from one medium to another medium, frequency will not change. Frequency will not change. But speed of changing, then what do you think? Wavelength should also change, na? Tell me, wavelength should also change, right? So can I say that, okay, C1 by C2 is actually lambda 1 by lambda 2, right? C1 by C2 is actually lambda 1 by lambda 2 because frequency is constant, so it will be cancelled, right? And don't you think that this can be written as refractive index of second medium with respect to first medium? Tell me. Think about it. Or mu2 by mu1. Mu2 by mu1. So suppose somewhere you get this problem, right? Either in TSU or any examination, right? That instead of speed of light, you are given wavelength. Can you find frequency? Sorry, can you find refractive index? Can you find refractive index? Or if refractive index is given and you are asked to find wavelength, right? Got it? This concept, note down in your notebook. This is one extra concept, okay? But it's easy, nah? It's same thing, right? Okay, so see, this is a table, right? I'll show you a table. This is a table, right? So we have different substances and different refractive index. Now, if you observe that diamond have highest refractive index, obviously there might be something which have more refractive index than diamond. I'm talking about in this table, right? Basically, it is the substance which we generally know. Diamond have very high refractive index. Yes or no? Right? Yes or no? And diamond shine a lot. Diamond also shine a lot, right? Now, don't you have, is there any relationship between diamond shining and the refractive index? Think about it. Is there any relationship? Tell me. What do you think? Why diamond shines, right? Very good. Multiple refraction of light. Okay. Yes, very good. Now, when we talk about this refraction, right? After knowing the basic concept about refractive index, refraction and all, okay, there's a phenomena called as total internal refraction. Yes or no? How many of you remember that? Tell me how many of you remember this? There's a phenomena called total internal refraction, right? Sorry, total internal reflection. Yes, total internal reflection. Very good. Okay, so we will discuss about that, but before that, let's try to solve one problem. Okay, let's try to solve one problem. We will see the application of refraction. Okay, right? We will see the application of refraction. There are lots of concepts which is covered under that, but before that, try to solve this very easy problem. Okay, guys, try to solve this easy problem. So we have this problem, right? The refractive index. Wait, just wait for this to go. Okay, yeah. So the refractive index of water is given. The refractive index of glass is given. You have to calculate the refractive index of glass with respect to water. Easy, super easy questions. Tell me, super easy. Okay. Abhishek, you are getting. Zaiba, you are getting. Dipanshu, Angha, Devanand, Mohan, you are getting Mohan. Very good, Pragna. So you just have to remember one concept, right? You have to find what? You have to find the refractiveness of glass with respect to water. So it will be refractive index of glass, divided by refractive index of water. What is refractive index of glass? 4 by 3 divided by refractive index of water, 3 by 2. So it will be, tell me, 8 by 9? Yes or no? No, because I have taken opposite, right? This is of water, this is of glass, right? Okay, so this is opposite, right? It should be 3 by 2 by 4 by 3. So 9 by 8. Okay, got it? Easy. So these type of problems will be easy. Yes, very good. Now, this is just for one medium. If we have multiple mediums, now let's think about it, right? Let's think about one scenario. Okay, let's think about one scenario. Okay, instead of covering TIR, let's try to understand the concept of refraction a lot. Okay, right? Now, suppose I'm having this. Wait. Suppose I'm having yeah, I'm having a glass slab. This is a glass slab. This is a glass slab, right? Suppose this is a glass slab. Okay, think about it. Everyone think about it. Okay, so this is suppose glass one. Now again, I'm having suppose another glass slab. Wait, what happened? I'm having another glass slab like this. Okay, another glass slab of some random thickness. Right, this is your second glass slab. Okay, now then again I'm having third glass slab. Suppose third glass slab. Right, like this. Okay, right? Anyone have any issue? We have 3 glass slabs. Now let's see what happens. So normal will be same now. Normal will be same, right? Same means it will be perpendicular to this line only. Okay, that's the meaning of same, right? So suppose I'm having this as normal. Suppose in this case, right, I'm having this line as normal. This line is normal. Okay. Right? And this is an incident ray. Just imagine that this is an incident ray. Okay, this is an incident ray. Got it? Right, everyone? Now tell me. I'll just wait. I have made this angle is a lot, right? I'll just make a smaller angle like this. Okay. Now, if you think about it, right? I should have made a bigger rectangle. Decrease this angle again. Okay, let it be like this. Okay, so suppose this is my incident ray, right? But we know that this incident ray will not pass through these 3 glass slab like this. Agree? Yes or no? Tell me. Yes or no? What will happen? What will happen? Think about it. If I'm talking about this line, right? If I'm talking about this line at this point, I can say that this is air, and this is glass, and refractive index is suppose mu1. Wait, refractive index is mu1. Here refractive index is again mu2, and here refractive is again anything else which is mu3. There are 3 refractive index. Okay, 3 different refractive index. Makes sense? Rarer medium, and the information that I have given you, mu1 is less than mu2 is less than mu3. Okay, this is the information that I have given you. Mu1 is less than mu1 is mu2 is less than mu3. Okay. Now my question is, suppose this angle is I, right? This angle is I. Okay, I'll just do it step by step. Try to understand what happens. Now this line actually it will bend toward, right, away from the normal or toward normal. Tell me, this angle of incident will bend toward the normal or away from the normal? Think about it. Toward the normal or away from the normal? Very good. Toward now, far, because this is your denser medium, right? Air is your rare medium. Air is mu. I'll just write it as mu. Okay, and mu is less than mu1. Mu is less than mu1 is less than mu2 is less than mu3. So this is your rare medium. This is denser as compared to air. So it will bend, right? It will bend like this. Yes or no? Tell me. Yes or no? Anyone have any issue in this? Tell me. Anyone have any issue in this? Any issue in this? Try to understand, right? Try to understand step by step, right? It is actually multiple steps. Okay, and we will do the same thing. Now forget about this. Now forget about this. Now at this point, this is your normal. At this point, this is a normal. Yes or no? Tell me. Yes or no? Okay, got it, right? And this is the angle of incidence. This is the angle of incidence. Now again, mu1 is less than mu2, which means this medium is mu1, right? This medium 1 is rarer than medium 2 or denser than medium 2. Tell me. I'll just write it like this. It is 1 This is air, this is 1, this is 2, this is 3, and this is again air. This medium 1 is denser than medium 2 or rarer than medium 2? Rarer, right? Means medium 2 is denser, medium 1 is rarer. Very good. So again, it will bend, think about it, it will bend away from the normal or toward the normal? Again, it will bend toward the normal, right? So I'll draw it like this. It will bend again like this toward the normal. Make sense? Make sense? Anyone have any issue? Tell me. Anyone have any issue? Think about it. Step by step, same thing I'm doing. Yes or no? Okay. Now let's see again at this point, right? At this point, I can say that at this point again we have one normal. Okay. Again we have one normal. Again we have this line, refracted ray. Okay. Step by step. Or I'll just remove this last one because it might be too much for you to understand. I just remove this last one. I just remove this last one. I'll have only 2 slabs. Let's take only 2 slabs. Okay, right? It's easier to understand. Let's take only 2 slabs. Now think about it. Just 2 slabs, right? I don't have a third slab, right? I don't have third slab. Now, when you talk about this second slab, right? Now, second medium, the second slab is denser than this, obviously, air, yes or no? The second slab is denser than this, right? Now, if light will come out of this, if light will come out from this, right? What do you think? It will bend away from the normal or toward the normal? It will bend away from the normal or toward the normal? Very good, away from the normal, right? It will bend away from the normal. So it will bend like this. It will bend like this. Okay, it will bend like this, right? Now, do you observe something? Do you observe something? Yes, very good, Dhruv, right? These 2 lines will be parallel. These 2 lines will be parallel. Yes or no? Right? How come? Can you prove? Can you prove? How many of you can prove that these 2 lines will be parallel? Tell me. Because if I'm saying that these 2 lines are parallel, I'm saying that this angle is also I. Yes or no? Tell me. I'm saying this now, that this angle should also be I. Tell me, yes or no? Because if these 2 lines are parallel, I'm saying that this angle is also I, right? So if somehow I can prove that this angle is also I can see that these 2 lines are parallel, right? Now, just take a pause, okay, and try to understand. Everyone understood the concept, yes or no? We will talk about the calculation part, right? But everyone understood this basic concept, yes or no? Everyone, every single one of you. This is very basic concept, right? It's not that something which you haven't studied, right? I'm just using the application part, right? Very good, Suktika. Very good, everyone. Maurya, you're getting? Harsh is here. Krish, Afaq, Mohan, everyone is getting? Okay. Now let's try to figure it out. Let's try to figure it out. Okay, how this is possible. Okay, so let's do this. Now suppose this is angle I. This is angle I. So I can say that okay, this is what? Sorry, not this. My bad. Okay, this angle is angle R. Yes or no? I'll just write R1. Yes or no? Tell me. This is angle of refraction. Yes or no? step by step. Everyone do this with me. And this line and this line parallel. This is your transversal. And this is your what? This is also your R1. Yes or no? Tell me. This should also be R1. Right? This angle. This angle is R2. Suppose this angle is R2. So this angle is also R2. This angle is also R2. Anyone have any doubt till this step? Anyone have any doubt till this step? I'm just using basic lines and angle concept that we have studied in class 7th. Okay, right? Very good. Now, I hope all of you remember Snell's law. Okay. Now, let's use Snell's law. Let's use Snell's law. Okay, I'll just shift this picture, right, till this point. Okay, now let's use the Snell's law. First of all, how many surfaces do we have? Tell me, how many surfaces do we have? Refraction is occurring at how many surfaces? Tell me. Tell me and let me know how many surfaces? 3. Very good, Shanti. Very good, Pragna. Very good, Dhruv. 3 surfaces. This is surface 1, right? This is surface 1, surface 2, surface 3. So refraction is occurring at 3 surfaces, right? Very good, Abhishek. Very good, Renuka. Very good, Suktika. Right? So how many times do we need to use Snell's law? Ask yourself. Step by step, you should ask yourself, how many times do we need to use Snell's law? How many times? Very good, Zain. Very good, Renuka. 3 times. Very good. Let's use this, right? I'll just write step by step. Okay. So at surface 1, at surface 1, surface 1. Okay. I'll write. So this is mu air, right? So I'll just write mu sine I. Okay. And I don't know if it is I. I'll just write it as I dash. I'll just write it as I dash. Okay. So mu sine I is equal to mu1 sine R1. Sine R1. Right? This is first equation. Right? At surface 2. Mu1. This is surface 2. Mu1 sine R1. Mu1 sine R1 is equal to mu2 sine R2. Mu2 sine R2. Make sense? Yes or no? Make sense? Now, mu1 sine R1. Mu1 sine R1. Can I replace this mu1 sine R1? Tell me. Can I replace mu1 sine R1? Mu1 sine R1 here, mu1 sine R1 here. Can I replace this? Yes? Very good. So I'll write like this. Instead of mu1 sine R1, I'll write mu sine I is equal to mu2 sine R2. This is B. Now add surface 3. Add surface 3. Add surface 3. Again same, again Snell's law. Again Snell's law at surface 3. What I'll write? This is mu2 and R2. Mu2 sine R2 is equal to, this is again air, no? This is air, mu sine I dash. I don't know if this is I or not. I'll just write as I dash. Now think about it. Think about it. Again, think about it. Okay. So this is mu2 sine R2, mu2 sine R2. Can I replace it? Tell me, can I replace it? Right? Let's replace it. Let's replace it. So mu sine I is equal to mu sine I dash. I dash. Right? Now mu will get cancelled. So if I'm having sine I is equal to sine I dash, because this will get cancelled now. Can I say that I is equal to I dash? Tell me, can I say that I is equal to I dash? Yes or no? Tell me yes or no. Yes? Got it? No. Yes, na. If sin I is equal to sine, if sine of two angle is equal, then the angle is also equal. Okay, right? Because this angle will be 0 between 0 to 90 only, right? This I will be 0 to 90 only. Okay, right? This is not maths where it will be in second quadrant, third quadrant. It will be just between 0 to 90. So in 0 to 90, right, there's only one value now. Got it? Tell me, got it? Everyone got this concept? So we proved it that doesn't matter how many medium we put, right? Doesn't matter how many medium, 2 medium, 3 medium, 4 medium, right? If the light is traveling from, right, one medium and like emerging from the same medium, right, it will be same. So if I think about it, right, suppose instead of this, suppose if this will be light, suppose this will be the incident ray, don't you think this should be your emerging ray? Tell me, this is an emerging ray, yes or no? This is an emerging ray, yes or no? Tell me, yes or no? Right? And this is called as, this is, right, this is one of the concept, okay, right, this is called as law of reciprocity, means the path, right, is followed by the path of reflected ray as incident ray will be followed in both direction. Okay, got it? Right, everyone, I hope all of you understood this concept. Tell me, all of you understood this concept? Very good. So what concept we learned here? We learned that doesn't matter how many slabs you put in between. You put 100 slabs, right? You put 100 surfaces. You don't have to worry about any of the surfaces. Just think about this and this, first and last. Got it? This is one important concept. You might think that this is a very simple concept, but this is a very important concept. Yes or no? Suppose if an exam, if I have given you 10 slabs, you would have get scared, yes or no? Tell me. Just tell honestly, right? If I would have given you 10 slabs, right, you would have got scared that how to do it and all those things. Okay, but doesn't matter if I give you 10 slabs, 100 slabs, right, with various refractive index, you just have to worry about the first surface and the last surface. All the middle surface will be neglected. Okay, got it? Yes, very good, everyone. Okay, so this is the concept of refraction. And if you see that this light is shifted with some distance, right? This is called as lateral shift. This is called as shift, lateral shift. Now, this is very important concept, very important concept. Okay, how this is important? Tell me how this is important. How many of you can say how this is important? Or have you ever, right, seen the real life application of or real life experiment where we can see the application of refraction? Tell me. Apart from mirage and looming, apart from mirage and looming, how many of you kept something in a bucket? And yes, in swimming pool, right? See, when you go to swimming pool, the floor of swimming pool seems very shallow, yes or no? Like it seems like it is just 2 or 3 feet. Think about it, yes or no? Right, but even though if it's like 15 feet or even 20 feet, it seems like it is just 2 3 feet, right? Yes. So there's a concept. I will cover one concept. I'll take you 10 minutes. Okay. There's a concept, very important concept of apparent height and real height. This is very important concept. 4 students already left. Apparent height and real height in a medium. In a medium. Now think about it. How many of you have seen this experiment when you kept your pencil in water. It seems like it is bent. It is bent, and when you keep a coin in a bucket, it seems like it is at a much higher depth as compared to the bucket of water. I hope all of this observation you would have done, right? Yes, right, Zain. Very good. Now, what do you think? What is the phenomena? What is the phenomena? The phenomena is this only, right? The phenomena is this only, right? I will give you the mathematical reason, right? The mathematical reason how this happens. Okay. Now, suppose I'm having a bucket, right? Suppose I'm having a bucket. This is a bucket. Right? Suppose I'm having a bucket. Okay. This is a bucket. I don't know when I'll just draw something without making any horrible mistakes. Okay. Right? This is a bucket. And suppose I'm having, okay, I won't be using this surface. Okay. Suppose it is filled with water, right? Suppose it is filled with water. Filled with water. Okay, till this height. Filled with water till this height. Okay. Right, it is filled with water till this height. Just imagine it is filled with water. Okay, makes sense? Now, what we are doing is we want to find the relationship between the real height and apparent height, and we will try to understand how this is different, how real height is different than apparent height. Okay, and how to calculate it. Okay, now think about it. Think about it. Suppose I'm having a coin which is kept over here. This is a coin which is kept over here. Okay, right? Now, whenever we talk about uh, seeing anything, right? The light should come from the object, yes or no? Step by step, light should come from the object, yes or no? Suppose you are seeing me, right? Or you're seeing anything, right? Light is coming from that object, na, right? It is getting reflected from source, right? But it is coming from that object. So suppose this is your eye. Suppose this is your eye. So I can say that light will be coming from this. Okay, I'll be using this red color. Okay, so light will be coming from this. Now, if you see this surface, right? If you see the surface, I can say that this is the surface of refraction. Now, in this surface, okay, at this surface, this is your normal. This is your normal. Now, this is denser medium, this is rarer medium. What do you think? Light will bend from rare medium to denser medium, right? Bend away from the normal or then toward the normal? Tell me, away from the normal or toward the normal? Away from the normal, na? Rarer medium to denser medium to rarer medium. Yeah. Denser medium to rarer medium. My bad, I asked the opposite question, okay? Right, so your answer is correct, right? But here it is denser medium to rare medium. So it will bend away from the, right, normal. So it will go like this. Yes or no, it will go like this. Make sense? Make sense? Yes or no? Right? Now, suppose, yeah, suppose take another ray. Suppose take another ray of this object. Okay, you can take actually normal also, right? For easy calculation, I'll just take this normal. Okay, for easy calculation, what happened? I'll take the second ray as normal. Okay, for easy calculation, I'll take the second ray as just normal. Just normal. Okay, because we know that if I'm taking normal, the incident ray, refracted ray, everything will be this at this line. Now, this is your eye. Suppose this is your eye. Okay, right? This is your eye. And you're observing this. So this ray of light, you will observe that this ray of light will be like this now, right? So according to you, you won't be perceiving this, you won't be seeing this red line. You will be seeing this line. Yes or no? Tell me. You will be seeing this line, this purple one, because that is your line of sight. Agree? Agree? Tell me. Yes? So obviously, according to you, the height of this coin will be this much now. This is small h and this is capital H. Okay, got it? This is capital H, this is small h. Make sense? Anyone have any issues? So what is capital H? Tell me, what is capital H? It is real height or apparent height? Tell me, what is capital H? Real height or apparent height? Very good. Capital H is real height. I'll write it down. Capital H is real height. Real height. What about small h? What about small h? Small h is real height or apparent height? Small h is very good. Apparent height. Height. Okay, right? Now, what do you think? According to this figure, which height is more? Real height is more or apparent height is more? Tell me. I'll just tell you a shortcut. I'll just tell you a shortcut. Real is more, right? So if I want to find the ratio, capital H by small h, it is greater than 1. Agree? Agree? When? When the object is in denser medium. Object is in denser medium. Yes or no? Tell me, yes or no? Okay. Now, last concept of today's class, right? I want to find it. How to find it? Let's take, right? So this is your, tell me, I can say that, just observe. I can say that this is your refracted ray, this is your refracted ray, and this is your incident ray. Yes or no? Tell me, yes or no? Yes. So can I say that? Can I say that this is I and this is R? Can I say this using the basic concept of parallel lines? This parallel lines, na? So this is angle R, this is angle I. Yes or no? Right? Let's name it. Let's name it, right? Let's say it as A, this is as B, this is as C, this point as D, this point as D. Okay. So can you see two right angle triangles? Can you see two right angle triangles? Everyone, can you see two right angle triangles? Tell me if it is too difficult for you to understand. I'm not using any other concept which you haven't studied till now. Now, don't you think that I can say that what is tan I? Tell me, what is tan I? Tan I, tell me, what is tan I? It is AD by AO, yes or no? AD by AO, step by step. And what is tan R? Tan R is nothing but, tell me, AD by AC, yes or no? Step by step, yes or no? Very good, Dhruv, very good, Zain, very good, Renuka. Now, what I want to do is take the ratio of this. Okay, sorry, take the ratio of this. Okay, right? So I'll just take the ratio. Can I say that tan I by tan R? Okay, wait, something happened. This got hanged. Okay, yeah. Wait, guys, I don't know what happened. My computer got hanged, I guess. It's not working. Wait, I'll just try using this. Okay. Tan I by tan R. Don't you think, what is tan I by tan R? AD will cancel? Yes or no? Tell me, AD will cancel? Think about it. Tan I is AD by AO. Tan R is AD by AC. This happened. This got hanged. Just give me 1 minute. This is the last concept. This is the last concept. Okay. Everyone try to do it by yourself, right? It will be AO by AC or AC by AO. Think about it. It will be AO by AC or AC by AO. It should be AC by AO. Think about it. Yes, it's back, right? So tan okay, tan I by tan R is basically AC by AO. Now, what is AC? Tell me, what is AC? AC is small h and AO is capital H. Yes or no? Till this point, anyone have any issue? Till this point, anyone have any issue? No? Easy? Okay. And using Snell's law at this point, using Snell's law at point D, using Snell's law at point D. Snell's law at point D. At point D. Can I say that sine I by sine R is equal to, now this is mu of water, this is mu of water, and this is mu of air. Mu of water divided by mu of air, yes or no? Or I'll just write like this. Mu of water with respect to air, yes or no? Now there's a very small concept, right? The small concept is these angles I and R are very small, right? These angles are very small. Okay. Now, if I and R are very small, then I can write tan I by tan R is equal to sin I by sin R is equal to I by R. This is the condition only if I and R are very small. Now we consider this to be small, by the way. Now if you relate it, what we will get? We will get H by capital H. H by capital H is equal to what? Tell me. So this is opposite. This is A by W. My bad. This is A by W. Okay. This is A by W. Okay. It is opposite now. This is mu of air by mu of water. Yes or no? Tell me yes or no. Or I'll just write like this. Capital H by small h is equal to mu of water with respect to air. I could have just told you the formula, right? But I wanted you to understand how we got this formula, right? Now think about it. Don't you think that this makes sense? Height of real height by apparent height is equal to refractive index of water, which is greater than 1, right? This makes sense. Now this makes sense. Yes. And don't you think that this formula is extremely easy? This formula is extremely easy, right? If I give you the actual height, and if I know the refractive index. Can I find the apparent height? Okay, so that's it for today, guys. I hope all of you understood the real application of refractive index, right? This is something which I taught extra, but this is the application of refractive index. You guys have studied this before? Okay, Abhishek, I'll explain. See, from Snell's law, you have to remember that if the angle is very small, then tan theta, right? I'll just write it right here. Okay, this is one concept of maths. If angle is very small, if angle is very small, angle is very small, then you can write tan theta is equal to theta if it is very small, and sine theta also equal to theta, right? So if you can write these as equal, then tan theta is equal to sine theta, na? Got it? This is one concept of maths. So you just have to understand and remember that this is the concept. Okay, got it, Abhishek? That's what I did. I related tan with sine. Okay. Now everyone, if you don't remember any of these, no issues. Just remember this: capital H by small h is equal to mu of, right? Tell me, mu of what? Water with respect to air if object is in water, right? If object is in air, then it will be opposite. Okay, got it? Okay, very good, Zayan, very good, Abhishek. Okay, I hope all of you understood each and everything and enjoyed today's class, right? Everyone understood each and everything? Raise your hand. Priyanshu, Kushagra, Shreya, Renuka, Suhan, Suhas, Yash. Okay, very good. Abhishek, I'll post this video. Right, within half an hour. Okay, please watch this video and make your own notes, right? I will always request you guys. It will hardly take 10 to 15 minutes. Watch it at 2x speed. Okay, right? But when you watch the video again and then make notes, now you will recall what we have studied. Because see, when I'm telling you something, your mind is accepting that as a fact, right? That sir to sahi bol rahe honge, but when you go and think on your own, then you realize कि नहीं मुझे समझ में नहीं आया. That's why always make a habit. Whenever teacher teaches, go take 15 to 20 minutes, right? Make your own notes. Okay? आज ही जाके क्लास खत्म होगा, हाफ एन आवर का ब्रेक लो, 1 घंटे का ब्रेक लो, घूमो फिरो खेलो, राइट? शाम को राइट 8 बजे के अराउंड बैठकर नोट्स बना लो. ठीक है? Make sense? And anyways, I'll send notes, na? I'll send notes. Okay. Chalo, thank you everyone. Thank you, Suptika, that you enjoyed today's class, right? My aim is that you guys should realize what physics is, how physics is associated with our real life. Okay, right? Let's hope that you enjoy physics. Okay, because it used to be my favorite subject. Okay, bye everyone. Bye, Abhishek. Yeah, bye bye.